C was designed by Dennis Ritchie, also known for the creation of Unix. In fact, its first application was to rewrite Unix, originally written in assembly language. This all happened in the early 70s. Hey, I wasn't even born yet. Gates and Allen hadn't yet founded Microsoft, and Cutler was still writing code for DEC. Sadly, Dennis Ritchie passed away in 2011 at the age of 70, but we'll always remember him as the creator of C. In those early days, it was widely believed that serious OS development had to be done in assembly. C put an end to that myth, thanks to its relatively simple design and strong hardware affinity. C has changed little over the years, a testament to the language's brevity. That is, it's not a big language. It may appear complex at first, but this usually has more to do with your previous experience than it does with C. The history of C is very much tied to a book entitled The C Programming Language, written by Brian Kernighan and Dennis Ritchie, who worked on Unix together. Given the authors' names, the book came to be known as KNR, and has in many ways set the standard for programming books, having influenced a generation of programmers and language designers. This book is also, though not officially, regarded as the standard definition for the language. At well under 300 pages, it's a testament to the language's relative simplicity. The second edition of this book covers the 1989 ANSI standard definition of C. Although not the latest standard, the 89 version, dubbed C89, is the version used almost exclusively today and will be the focus of this course. C is also a subset of C++, so will form a good foundation for later study and use of that language. In fact, the C syntax is so popular that its design is often copied by other languages. C#, Java, JavaScript are all good examples. It's hard to know for certain why C is called C. It was somewhat influenced by a language called B, but there was no A. B itself was a simpler version of BCPL, which some C programmers jokingly insisted stood for the Before C programming language. BCPL was, however, based on CPL, which officially stood for the Cambridge Programming Language, since its designer was from Cambridge University. Ironically, his first name was Christopher, and some maintained that the C in CPL stood for Christopher. So whether C is called C because it follows B, or because there was once a guy named Christopher from Cambridge, we may never know, nor does it really matter. C is a multi-purpose programming language. It's not dedicated to any specific function, such as web development in the case of JavaScript, or data access in the case of SQL. It isn't tied to any specific operating system or associated with any particular company, like Java is with Oracle and C# is with Microsoft. C is often called a system programming language due to its effectiveness at producing operating systems and system tools like compilers and debuggers. What makes C so useful and in many ways unique among today's languages is that while it abstracts the machine architecture, things like machine instructions, registers, and calling conventions, it maintains a close relationship with the machine, providing a very concise and efficient representation for the same types of primitives that machines themselves naturally deal with. Things like numbers, characters, and machine addresses are directly supported in C without any runtime cost. C proved that serious system programming could be done in something other than assembly. This was a critical turning point in the history of computer science. A C compiler is now available on virtually every platform for virtually every operating system, from the tiniest microcontrollers to the largest and most complex of systems. Today, C is at the heart of practically every mainstream operating system and device, from Unix to Linux, Windows NT to Windows 8, Apple OS X to iOS. Even many systems that claim to be written in C++ are often written predominantly in the C subset of C++. So C is everywhere, and its relevance cannot be overstated. Getting started shouldn't be hard. All you need is a command line compiler and a text editor. Larger projects may require more sophisticated tooling, but there's nothing quite like learning a new language with Notepad and the command prompt. As I said, there's a C compiler, and likely a free one at that, on practically every platform. For this course, I'm going to use the Microsoft C++ compiler on Windows. Again, it's also freely available, but you should be able to follow along with virtually any C compiler on any platform. The differences should be minor enough for you to easily keep up. If you're using the Microsoft compiler, the command is cl.exe. Yours might be something else, traditionally CC on Unix, or GCC for the popular open source compiler. Now the first thing any C program needs is a main function. This function represents the entry point into the program as far as the C compiler is concerned. It's a function like any other, but it's treated specially for that purpose. As a function, it has a return type, in this case int, and int stands for integer. Following the name, you have these parentheses. Now, within the parentheses, you might have a number of parameters. In this case, there aren't any, and sometimes you'll see the word void here, which just means that, again, the same thing, there are no parameters, but it's pretty redundant, so we tend to leave it out. Following that, we have these curly brackets, and the curly brackets provide the boundaries for the code that actually represents the function's body. All the things in here might be, changing variable values, creating variables, calling other functions, and so on, and finally returning some value. In this case, we're simply returning the value of 0. The semicolon here is the terminator for a statement. So if you have multiple statements on a single line, you simply terminate each one with a semicolon. Now this program doesn't do much, but it's a valid C program, so we can go and save it, return to the command prompt, and compile it. Again, as I said, I'm using the Microsoft C compiler, or the C and C++ compiler. And the command is cl, and then you type the name of the source file, and you hit enter, and it compiles it. Now, there's a bunch of text that just popped through the screen there, and if we scroll up, we can see that it tells us it's a certain type of compiler, and it linked the code, and it generated a first.exe machine code file. Now that's the executable that contains the actual program that we can run. So we can run first.exe, and it does nothing. But it worked fine. So now the next thing to do is return to the source file and make this program do something interesting. And the first thing we can do is use the printf function to print a friendly message. Now printf is a pretty amazing little function. But in this case, all we're doing is asking it to print the friendly hello world message. The /n here is called an escape sequence, and it represents the new line. And this is a special character that the command prompt will interpret as a new line character and will accordingly insert that new line into the command prompt's display. Of course, the compiler knows nothing about printf. This is just a library function that we need to tell it where to find it. And we do so by hash including the standard IO header file. Now hash includes, literally, or at least conceptually, includes the contents of this other file into the program, as if you'd copied and pasted it in there. Now that's about it. So we can save that program, return again to the command prompt, type cl first.c, compile it again, works great. Now we can go first.exe, run it, and there we get our friendly message. If we return to the program and remove that /n, that escape sequence, you can see the difference that it makes in this case. And here you see now there's no longer a new line following the message. Now you may have noticed that it's pretty hard to follow the command line output because of the verbosity, or all the noise and the extra information that the compiler emits to the command prompt. Now one thing you can do there is to clean that up a little bit by using the /no-logo switch. And what that does is it just emits what you need to in order to make sure your program actually compiled successfully. And there we go. Now another thing you can do, which is quite useful, is to use the W4 switch. And what that does is it increases the level of diagnostics or the warnings that the compiler prints out for possible errors in your code. This is generally a good habit to adopt, because you'll quickly catch a lot of errors that might plague you later on if you tend to ignore them. And finally, the other switch that is quite useful is the /TP switch. Now what this does is it tells the compiler, hey, assume that this code is C++ code rather than C code. By default, the compiler will see the .c extension on the source file and assume it's rightly C code. But if you compile it as C++ code, what that does is it gets the compiler's C++ engine to give it a much better look. There'll be better type checking, better error checking, and it also ensures that your code is a lot more portable and you can later on use it inside of a C++ program. Again, everything worked fine. We can run first.exe. Everything is as expected. And there's our first program.